Okay guys, so at this point you should have already gone through and watched the video and completed the problems on synthetic and long division. And we're going to jump into now two theorems. The first is going to be the remainder theorem and the second one is the factor theorem. So let's jump right in. The remainder theorem tells us that if we have a polynomial, and we're just going to call that polynomial p of x, and if we divide it by some factor x minus c, then the remainder is equal to the function evaluated at that 0. So why don't we do it once and then I can kind of try that together a little bit again. So we're going to use the remainder theorem to evaluate the following. So we want to find f of -4. Well, we just learned that plugging in -4 is the same as dividing by the factor x plus 4 and seeing what the remainder is. So we're going to do synthetic division. This is the value I'm evaluating at. So again, remember my factor would be x plus 4. But when I do synthetic division, I use the 0 from the factor. So that -4 is going to go here. Okay, so I'm going to do synthetic division. My coefficients are 1, 2, -6, -9. So I drop the 1. I multiply by -4. I multiply by -4. Add. I multiply by -4. Add. And I get -17. So this is my remainder. So what they're saying is when I do synthetic division with that value, my remainder is the same thing as f of -4. So that's what the remainder theorem says. Okay. So I'm sure you guys could do this one again, but we can just do it together. It says find f of 2. Well, remember it says, so if I want f of 2, that's the same thing as dividing by the factor x minus 2. Well, if I want to divide by a linear factor, I can use synthetic division with the 0. So my 0 is going to be 2. My leading coefficients are 1. My x cubed term is missing. That'll be 0. -4 to -1. Add, multiply, add, multiply, add, multiply. Oopsie, that's a +3. And that's my remainder. Well, remember what the remainder theorem says is if I use synthetic division, whatever I get for my remainder is the same thing as f of this number. So I can say in this case that f of 2 equals 3. So that's the remainder theorem for you. And it can be really helpful sometimes when numbers get really big. Like let's say I had to plug in 5 into this. I might not want to deal with x to the, or 5 to the 4th power minus 4 times 5 squared. Doing this process can sometimes be easier to evaluate. So let's move on to the factor theorem. The factor theorem says a polynomial function p of x has a factor x minus c if and only if when I evaluate it I get a 0. Well, this is why we call them a 0. Well, we just also learned that means my remainder would be 0. So another way of saying that is x minus c is a factor if and only if c is a 0 of p. So a quick thing to remember is that solutions, roots, zeros, and x-intercepts are the same thing. So let's take a look down here. It says when we find the roots of a polynomial equation, we're finding the places where the value of the function is 0. If f of x equals 0, then x is a root. So look what it's telling me. If I plug in 4 and I get out a 0, then I know that 4 is a 0 and x minus 4 is a factor. Same thing, if I plug in -7 and I get out 0, or what we learned from the remainder theorem saying my remainder is 0, that means that x equals -7 is a 0. Oopsies. Said -7, didn't write it. And x equals -7 is a 0, and x plus 7 will be a factor. Again, if I plug in 3/2 and I get 0, it means that this is a 0, and this is a factor. Sorry. So now it says, watch what happens when we find f of 3 for the function f of x equals x squared plus 2x minus 15. So it says, is your remainder 0? So remember, there's two ways to figure out what f of 3 is, and let me show you both ways so you can see they both work. Option number 1 is to literally just do it like this by plugging in 3. So if I plug in 3, I'm going to get 9 plus 6 minus 15. So that's 15 minus 15, which is 0. So f of 3 is 0. I can also do it with synthetic division. That's my second option. Well, I'm plugging in 3, so that goes in my box for synthetic division. My coefficients are 1, 2, and -. So I drop the 1 times 3, add times 3, And look at that. So you can see again that if I plug in 3 into my function and I get 0, it's the same thing as doing synthetic division with that value and seeing if you have a remainder left over. Okay, so is our remainder 0? The answer is yes. Well, if my remainder is 0, that means that 3, or x equals 3, is a root of my equation. Sorry guys, 1 second. A 0 of the function and an x-intercept on the graph. It also means that I have a factor of x minus 3. Okay? So the following says, is the given binomial a factor of my polynomial? Well, one thing we could do is try to factor this and see if it's a factor, but that takes a long time. So another thing that we can do is figure out if it's a 0. And I can do that by plugging in my 0, which is 1, in for synthetic division. So multiply, add, multiply, add. And then I'm going to multiply again. Did I make a mistake? Oh, yeah, sorry. I was like, something's not right here. Sorry, so I dropped it and I multiplied by 3. Whoopsies. And then when I add those together, I'm going to get 2 times 1 will give me 2. Then I add those. There we go. So now my remainder is 0. Since my remainder is 0, that means this divided into this evenly, which means it is a factor. So the answer is yes. Okay, so now we can do that again. We want to figure out if this is a factor. Now, an option is to factor this by hand, but another chance or another way to do this is just check to see if 3, which is my 0, gives me a remainder of 0. So again, my coefficients are 1, -1, 4, and then my constant term is missing. I have to put a placeholder for it. I'm going to drop the 1, multiply by 3, add, multiply by 3, add, multiply by 3. And now you can see I have a remainder of 30. Since my remainder isn't 0, that means this did not divide in evenly, therefore it's not a 0. Okay? If you guys have a problem like this, you can't just put yes or no. You need to show some kind of work that justifies your answer. So that's a quick overview of the remainder and the factor theorem.